In recent decades, Spanish rivers have been modified by numerous interventions that theoretically improve their hydraulic conditions and decrease the damage caused by floods. Ripraps, channels and dredging have frequently been employed to restrict river courses in an attempt to contain floods to within an increasingly narrower area. This approach has undergone a global reassessment in recent years, leading the European Union to enact a series of far-reaching directives, of which the Water Framework and the Floods Directives are among the most important.
There was very significant flooding in Central Europe, and in response, the European Union decided to enact a new directive affecting the entire Union, which establishes the obligation to improve flood risk management. After a lengthy approval process, the directive was adopted in 2007 and entered into force in 2009. The Water Framework Directive was then transposed into Spanish law. It is a very important directive which covers all aspects related to water, both in terms of quantity and quality, and establishes the policy to be implemented by member states as regards flooding and drought. At first, it was thought flooding could be controlled and prevented by carrying out large-scale channeling and dredging of rivers in order to protect flood-prone areas from inundation. But what happened? Although these interventions, channeling for example, may have lessened the risk to known flood-prone areas, in the end, all that was achieved was to move the problem downstream, relocating it. Downstream, what happened? An extremely marked increase in the water level.
The increased water level generated downstream of these structures has led to the emergence of new risks in areas which did not previously present any problems, and has significantly increased the risk that the existing containment structures might collapse when subjected to a hydraulic force for which they were never designed to resist.
And what we have seen in the photographs is that the rivers, these large canals, really the areas which have been subjected to the most sophisticated channeling technology in the world, do not work properly. And why not? Because their discharge and hydraulic capacity has been exceeded. And when this happens, the damage is much, much greater.
The consequence of this is the constant deterioration of both these containment structures, and thus the need for continuous investment, both to conserve those already in place and to construct new structures where flooding has become a problem, because of the channeling which has been carried out elsewhere. The end result of this policy of acting in localised areas is that the problem of flooding has simply been relocated from one area to another, leading to significantly increased costs and filling the floodplains with many small structures, which are not effective against a heavy flood and sometimes even exacerbate the damage suffered by nearby populations. In addition to the Water Framework Directive, the EU has enacted other directives that directly concern flood risk management, such as the Floods Directive.
This regulates all the interventions, studies and work carried out nationwide to define the flood areas, the areas at risk, and the plans the public authorities must formulate to assess these risks.
The entry into force of this directive implies a change in direction for interventions and objectives, and is the result of the conclusions drawn from the reassessment of the phenomenon of river area loss that has taken place in recent years. The new directive is based on the assumption that this loss of river area increases the risk of flooding, and it establishes the recovery of this space for the water to occupy when necessary as the primary focus of the new policy.
On the basis of the idea that flood proneness could be eliminated, the traditional approach has been to erect large structures in the rivers. In some cases, these structural measures have worked well and have reduced flood damage in towns and cities, but in other cases, especially when we are talking about the countryside or non-urban areas, this strategy perhaps needs to be reconsidered. Basically, the European Union is saying that the knowledge gained from the last 100 years of flood management indicates that eliminating flood proneness is impossible. We need to take a more modest approach, and instead of trying to drastically reduce the size of flood-prone areas, we need to start living with floods rather than fighting against them.
The development of a flood intervention model based on the restoration of floodplains is one of the key aspects of modern river engineering approaches and is based on fundamental concepts which have been scientifically formulated worldwide.
The Floods Directive represents the very first piece of legislation, and furthermore, legislation with very powerful legal scope of a directive which recognises the role, the extremely important role, of floodplains. Floodplains are simply places where rivers overflow, where, let's say, the water spreads out. Floodplains, that is, the areas alongside rivers susceptible to flooding, are fundamental for moderating floods in the sense that they store the floodwater and subsequently release it at a slower rate, thus reducing inundation downstream.
Concepts such as floodplains, flood abatement and lateral connectivity are now included among the objectives pursued by present-day river engineering. This new intervention model entails planning at river basin level and rejects the idea that water must flow faster in order to achieve the phenomenon known as flood abatement.
In hydraulic terms, the force of the current is reduced, it slows down, and the flood becomes, let's say, less intense. What a floodplain, an alluvial plain, does is to produce the phenomenon of flood abatement. Where the process of deposition or sedimentation predominate over the transportation processes that occur in channeled or narrowed rivers, what they actually do is to reduce the speed and level of the water, and that favours the phenomenon, let's say, of reducing the water flow rate, slowing it down. But what we have done in the last 2 centuries in Europe has been to eliminate these floodplains, these alluvial plains.
Since the entry into force of the latest legislation, 55,000 metres of dikes have been demolished to date, and another 8,000 metres of dikes and ripraps have been relocated further away from the riverbed, representing the recovery of some 1,000 hectares of floodplains, increasing their capacity for flood abatement and the ecological value of riverbanks and plains. The underlying idea is that by restoring the connectivity between the determined stretches of river and their floodplains, the hydraulic capacity of the rivers in the case of flooding will be greatly increased, since they will be able to absorb more water in a controlled fashion. In order to restore this connectivity, the existing containment structures must be relocated so as to make maximum use of the hydraulic capacity of floodplains to contain floods. The technical name for this relocation of containment structures is setback.
Conservation of the plains entails, above all, not constructing dikes, that is to say longitudinal embankments, very close to the river, and by river I mean the permanent channel, because these curtail, even sever the river's capacity to receive water, store it, and then release it more slowly. For this reason, the wisest course of action to take in order to recover the river's capacity is to move back, or set back as we say in engineering, the dikes as far as possible from the water from the river channel.
On the basis of these premises, and within the framework of the National Strategy for River Restoration, the Duero Hydrographic Confederation has recently formulated a management plan for one of the most problematic rivers in the Duero Basin in terms of flooding, the Orbigo River.
Reducing flood risks does not imply decreasing the size of flood-prone areas, but rather attenuating the damage caused by floods. A good example of this strategy of ensuring that flood management is compatible with a river's ecological integrity is the Órbigo River Project. Although the Orbigo River is controlled, flooding still occurs. There are many villages which are located close to the river channel, and traditionally these have protected themselves from flooding in a disorganized way, bit by bit, building dikes and riprap structures, sometimes raising them higher than the level of the surrounding terrain and confining the river.
Despite the channelling work that has been carried out for decades along the Orbigo River, lack of planning at river basin level has meant that this work has simply relocated the problem of flooding from one area to another, generating unacceptable risk situations for villages located along the length of the river. This situation has also created the need for new infrastructures, as new weak points are detected in existing structures, leading to an unsustainable economic scenario due to the continuously increasing necessity of carrying out interventions on unsuitable channelling.
The Water Framework Directive places great emphasis on the need to analyse costs in all issues related to water, not only the cost of what is done, but also the cost of what is not done. What happens when rivers are channeled? Channeled rivers do not work well hydraulically. You could say that to some extent they are hydraulic aberrations. The river, with its continuously varying flow rates, is at variance with the unnatural morphology of a channel, which is unsuitable for the transport of either liquids or solids. This implies continuous maintenance work, which is extremely expensive.
In 2011, after investigating 3 years of work in formulating a plan to improve the ecological integrity of the Orbigo River within the framework of the Floods Directive, the execution of the project began, with the dual goal of rectifying this scenario of constant threat to the population and reducing the maintenance budget.
The project for restoring the ecological integrity of the Orbigo River encompasses several types of intervention, but perhaps the most crucial action, and the one which has been given greatest priority, is to ensure the river's lateral connectivity. This has basically consisted in increasing the size of the floodplain, because over the years what has happened has been the plain has been occupied or reduced in size in order to use it for various purposes.
The project has been designed to encompass the entire river basin, and the goal is to reorganise all the infrastructures constructed along the riverbed by removing them from their current location and relocating them so as to improve the effectiveness of the floodplain in terms of transporting and releasing floodwater.
In order to plan a project of this nature, it is obviously necessary to carry out a hydrological study and to collect all possible data, including historical data such as old aerial photographs and information on the original morphology of the river and location of these floodplains. This all enables us to determine how far back to set the dikes and how high they need to be to provide complete protection using statistical data on recurrence intervals over some 500 years in order to be certain, or as certain as we can be, that the areas we want to protect will be safe and, of course, to improve over the previous situation.
The scale of the Órbigo River Project and the objectives it pursues present a series of challenges for the Confederation technicians involved in its implementation. One of the most crucial of these is to raise awareness about the project and its objectives among those who will be affected, so that people living near the river and those who use it understand and accept the scope and importance of this work in their area.
One of the aspects considered most important during both the project planning stage and execution of the work has been the involvement of the people who will be affected by the project. That is, not those of us who were involved in drawing it up, but rather those who will suffer, as it were, the consequences of the intervention.
Months before commencing the intervention, Duero Hydrographic Confederation technicians implemented an information campaign among the municipalities that would be affected, initiating a process that often required several meetings in order to be able to resolve the doubts and uncertainties raised in the public participation process regarding the safety of the population.
It was difficult at first for us to accept this project because we thought they were going to bring the river into the village, but now we can see that once the work is finished, people are going to be much safer, the riverside walk will be much nicer and much more accessible to people, and they will be able to see the river. What I mean to say is that the council believes that this intervention will be extremely positive for the municipality. There were some problems at first because this intervention was very different to anything else which had been carried out previously. Before, any interventions aimed at protection involved implementing harsh measures on the very banks of the river itself. So, although the local people were resistant at first and thought that they wouldn't be properly protected, bit by bit, using simple concepts such as if you let the water spread out, the level won't rise so much and it won't flow so fast, they started to understand and accept the idea and finally ended up supporting the project. I think that the biggest surprise was that we didn't understand the project very well on paper, the theory and how it would work in practice. We asked for a meeting with Ignacio Santillan, who very kindly explained the project to us again in detail, and eventually we realized, people have realized, that the solution is good in theory because what it does is to stop the river from being so narrow so that the water doesn't gather so much speed but spreads out so that it slows down and spreads out to the sides. It has been a complicated job which has taken a lot of time, but ultimately what it has allowed us to do is to achieve a final draft of the project and then be able to execute it.
The Órbigo River Project distinguishes between two distinct kinds of river area on the basis of the potential risks of flooding they present.
We defined these areas as places where present-day uses are incompatible with flooding, and others where they are compatible. Where uses are compatible, the dikes are completely removed, transforming the entire area into a floodplain. These areas usually consist of popular plantations which are not only perfectly compatible with flooding, but in fact it is even beneficial for such plantations to be flooded regularly, as the trees grow more quickly, and so the economic returns are better. But where housing, recreation areas or the like have been built on the floodplain, in other words, where there is anything that requires protection, the dikes are relocated further back, moving them away from the immediate vicinity of the riverbed and reconstructing them as far away as possible, whilst still providing the protection required.
In short, implementation of the project consists in taking advantage of all the materials used to construct the ripraps and dikes, which until now had been built in an uncoordinated fashion and confined the riverbed. To this end, several teams work simultaneously in different areas along the river. While one of the teams removes the old structures and transports the materials to storage areas, a second group uses these same materials to construct a new dike. Once the material has been collected and stored, it is then transported to the new location of the dike. These new dikes are designed and scaled to contain flooding greater than the recurrence interval over 500 years, and are built in such a way as to maximise their effectiveness. The exterior of the dike is composed of lightweight materials that will support plant recolonisation, thus integrating the structure into the landscape. Large stone blocks taken from the old ripraps are laid at the base to provide the structure with the stability to resist a flood, and these are placed below ground level in order to prevent the current from dislodging them and causing the collapse of the entire structure. Lastly, in those areas where this is necessary, the face which will be exposed to the river is clad with smaller stones to solidify and strengthen the entire structure. Technically, the work is not very complex, but it does require perfect planning of the sequence of tasks. In this way, the safety of local populations is ensured throughout the implementation of the project, and the need for new materials is minimised. Benefits to the population include opening access to the riverbanks in areas for recreational purposes, where previously the existence of a sharply sloping bank prevented this, and, of course, the high environmental added value. Restoring connectivity with the floodplains means that various natural processes are reinstated, and this in turn leads to an improvement in the environment without having to undertake any specific actions to achieve this ecological enhancement. This is another of the basic aspects addressed in the Water Framework Directive, which establishes environmental enhancement as one of the goals in addition to flood risk management.
River hydraulics and river restoration go hand in hand. If a river works well hydraulically, it will also work well from an ecological point of view. These two aspects are mutually complementary. What does not work in this way is a river transformed into a canal, because in order to do this we have to exert full control over its flow, and not just over the flow of water, but over the flow of solids as well, which are what basically determine the uniqueness of a river as compared to a canal. A canal can never be compatible with ecological integrity. On the other hand, safety is increased by expanding the size of the floodplain, and on the other hand, ecological integrity is slowly improved through the action of the river itself, simply by creating the optimum conditions for the river to evolve more or less naturally.
Through the National Strategy for River Restoration, and in compliance with the Water Framework Directive and the Floods Directive, the Ministry of Agriculture, Food and the Environment is committed to the improvement of flood protection in an economically and environmentally sustainable manner. The Orbigo River Restoration Project is the first major intervention in this field, and the conclusions that are reached will guide the planning of new flood interventions.
The Órbigo project is a forward-looking project. For once in river hydraulics, we can say that we took the lead, the initiative.
So this project is, in the end, a good example of how river restoration can be used not only to improve flood protection and to improve the ecological state of a river, but also to provide economic benefits locally.
The people are confident that there won't be any problems, that the project is beneficial for everyone. I think that after ending the Orbigo project, all the results coming from its monitoring will provide a huge change in the methods commonly used in controlling floods. In this way, I hope this kind of project will be more sustainable economically in the future, with a great increase in the safety of people against flooding, as well as in the ecological status of our rivers. I think that the Órbigo River project represents a unique and pioneering effort, and perhaps taking into account the kind of river we're discussing, it is also the most far-reaching and important intervention that has been carried out in Spain in recent years from an environmental, hydrological and ecological point of view.